In this video, we'll run linear regression on the data set. We'll first use just one predictor. So we're looking at education and salary. So since education is related to salary, so we want to predict salary based on our knowledge of the educational level. So to run linear regression, and go to analyze, and then regression linear. So the dependent variable is the salary, and the predictor is education. So we don't have one predictor and one outcome variable. So let's check the statistical button. We'll check confidence interval 95%, and we also will check descriptives and continue. In the save button, so I'm going to check the unstandardized predicted value and unstandardized residuals. So what it does, it will give us the predicted value and also the prediction error using the regression equation. So continue, and then let's check the options. It looks good. Continue, and then OK. So this is the output. The first table is a descriptive statistics for salary and education. That the average salary in among the 10 people is $4,100. Standard deviation $3,300. And then the average years of education is 12.9 years, and this is standard deviation 4.25 years. Yeah. It also gives us a correlation between salary and education, which is 0.826, and this is also significant. So the regression output is comes after. So the first regression table is the model summary, so which tells that what is the first, the multiple R is the same as the correlation. 0.826. So that's just the correlation between the predictor and the outcome variable. And the next one is R squared. So basically just the 0.826 squared. And so this tells us that about 68.3% of variation in salary can be explained by years of education. This is just R squared. The interpretation is similar to R squared. And this is the standard error of the estimate. Basically, what's the error, the average error among the regression line. So once we fit the regression line, we would expect the standard deviation around the Y variable will be reduced, because initially, when we look at the salary, the average standard deviation is 3.1. And now, so after we add education in the model, the standard deviation that's reduced. And so there's less error in the prediction. If we don't have, we do not know education, there's more error when we predicting salary. So that's what it means. The next table is ANOVA table, and basically this is a test of the regression model. Since this regression, we only have one predictor, so basically it's just a test for that one predictor. And so it comes out significantly if we look at the sigma value, because sigma value is less than 0.05. So meaning that we have a significant regression model, or basically the predictor is significant in predicting the outcome. And then the next one, the next table is the coefficients table. So in the coefficients table, we will get our regression coefficients, that is the regression slope and the regression intercept. So these are the numbers that we use to write the regression equation. Let me see that. So if we write the regression equation based on this, so that will be y prime as a predicted salary that will be equal. So the intercept, that is negative 3.708, then plus the regression slope 0.605 and times x, which is the years of education. And so the regression slope, it is positive, meaning that it's a positive relationship between education and salary. So since we have this regression slope, we can interpret that as one additional year of education can bring how much unit change in the salary. And so it tells us that with one additional year of education, a salary will increase by $605. So that's how we interpret the regression slope. And there's also a test of the slope, which is the t-test. And this is p-value associated with the t-test. You can see that this is significant because it is less than 0.05. So there's a significant regression slope, meaning that the years of education is significantly related to the salary. So that is so if we go back to the data view, we can see that we have two additional columns added to our data. This is the predicted value, and this is the residuals. That's just the differences between the observed salary and predicted salary. So the predicted column is just using the regression equation. We can calculate what's the predicted salary, and these are observed salary, and this is the difference between those. So this video shows how we run linear regression with one predictor and how we interpret the output and to get the predicted value and the residuals. Thank you for watching it.